The transaction rollback mechanism is responsible for restoring database state to a consistent point following abort, failure, or explicit user cancellation. Rollback operations execute in reverse chronological order relative to the original transaction sequence. The mechanism maintains an internal operation journal that records all state modifications, including write operations, index updates, and lock acquisitions. This journal persists in memory until the transaction reaches terminal state. Rollback initiation occurs through three primary pathways: explicit user invocation via the rollback command, automatic triggering due to constraint violation or deadlock detection, or implicit invocation following system interruption or timeout expiration. Upon initiation, the rollback subsystem enters a controlled state where no new operations are accepted on the affected transaction. Existing locks remain held until all undo operations complete. This ensures atomicity of the rollback sequence itself. The operation journal stores metadata for each state modification: operation type identifier, affected page or row identifier, before image data, timestamp, lock mode, and completion flag. Before image data contains the exact byte sequence that existed prior to modification, allowing bit-exact restoration. The journal occupies allocated heap memory with configurable maximum size. When journal capacity approaches the configured threshold, the system issues a diagnostic log entry but continues operation. During rollback execution, the system traverses the operation journal in reverse sequence. For each recorded write operation, the before image data is restored to the original storage location. Index entries created during the transaction are removed through standard index deletion logic. Locks acquired during the transaction are released according to the reverse order of acquisition. Cascading rollback behavior is disabled. Only the target transaction is affected. The before image restoration process verifies data integrity through checksum validation. Each before image record includes a computed checksum at storage time. During restoration, the system recalculates the checksum and compares it with the stored value. If discrepancy is detected, the restoration operation is logged as a warning but proceeds with the original before image data. This permits recovery even if transient corruption occurred during journal storage. Lock release during rollback follows a fixed protocol independent of original acquisition order. All exclusive locks held by the transaction are released first in reverse acquisition sequence. Shared locks follow the same pattern. Lock release triggers the lock manager to evaluate any pending lock requests from other transactions. This may result in additional transaction transitions, but does not alter the rollback sequence. Pending transactions remain suspended. Index rollback operations remove all entries that reference data modified during the transaction. The index subsystem maintains a separate index modification journal during each transaction. During rollback, the index modification journal is traversed in reverse, and each index entry removal operation is executed. If the index structure becomes unbalanced due to mass removal, a background rebalancing operation is scheduled, but does not block rollback completion. Constraint restoration ensures that the final state after rollback complies with all defined data integrity constraints. Referential integrity constraints are checked after all before image data has been restored. If a constraint violation is detected in the rolled back state, a diagnostic error is logged. However, rollback does not abort. The final state is guaranteed to represent a point in time prior to the aborted transaction's execution. Transaction state transitions during rollback are: rolling back is set immediately after rollback initiation. Operation journal traversal begins. For each operation, the corresponding undo action is executed. Completion state is tracked as rolled back once all operations have been undone and all locks released. The transaction entry remains in memory for a configurable duration to permit client notification and diagnostic inspection. Memory reclamation occurs after a transaction completes its rollback sequence. The operation journal memory is deallocated and returned to the heap. Any temporary structures allocated during transaction execution are freed in reverse order of allocation. The transaction control block is marked for eventual cleanup. Memory reclamation does not occur immediately. A background garbage collection process executes periodically to consolidate freed regions. Deadlock detection and automatic rollback operate as follows. When a circular wait condition is detected, the deadlock resolution algorithm selects one involved transaction for rollback based on transaction age, resource count, and priority. Automatic rollback is initiated on the selected transaction. The other transaction is notified that the blocking condition has been resolved. This occurs transparently. Application logic need not implement deadlock recovery. Timeout-triggered rollback occurs when a transaction exceeds its configured time limit. The timeout threshold is specified per transaction at initiation time. If the threshold is exceeded before transaction commit, a timer interrupt is delivered to the transaction subsystem. Rollback is initiated regardless of transaction state at that moment. Partial operations complete normally but contribute to the rollback sequence. No explicit client notification is generated. Applications must monitor transaction status. SavePoint rollback is a specialized variant that restores state to an intermediate point within an active transaction. SavePoints are named markers established via the SavePoint command. The operation journal maintains SavePoint records that segment the operation sequence. Rollback to a SavePoint undoes operations recorded after the SavePoint marker, but preserves operations prior to it. The transaction remains active after SavePoint rollback completion. Nested transaction rollback behavior depends on transaction nesting depth and isolation level. Rollback of a parent transaction automatically triggers rollback of all child transactions. Rollback of a child transaction does not affect parent or sibling transactions. The operation journal maintains hierarchical markers that track parent-child relationships. Rollback operations respect this hierarchy. Child transaction journals are discarded as part of parent rollback. Error handling during rollback execution follows a fault-tolerant protocol. If a specific undo operation fails, the failure is logged with full diagnostic context. The rollback process continues with subsequent operations. A single failure does not prevent rollback completion. After all operations have been attempted, a summary report is generated indicating the count of successful undos and any failures encountered. Rollback is considered complete regardless of intermediate failures. The operation journal is persisted to disk when configured with durability mode enabled. Journal pages are written asynchronously to a designated log file. Disk synchronization occurs at configurable intervals or upon explicit flush requests. If system failure occurs during rollback, the journal can be recovered from the disk log upon system restart. Journal recovery ensures that incomplete rollbacks can be completed deterministically. The recovery process is transparent to application logic.